there's a sort of question, there's a poll tool, and it'll just like a feedback questionnaire. So we'll run that and get your feedback at the end of the session. So thank you all for coming, and I hope you find it very useful. Over to Mark.
Great, thanks a lot, Debbie. Right then, so let me share my screen. So yesterday we got up to, come on, okay, repeating actions with loops. So the first thing to ask is have anyone got any questions or things that weren't clear or anything they want to go over on that or yesterday? Do just unmute and call out. Doesn't sound like it. Okie dokie. Right, so for the first probably hour or so, I will continue teaching actual Python syntax and how you code with Python. But actually, and after that, I'll have gone through all the Python that you really will need to know, unless you want to do serious programming with it. But to do data analysis, data science, that kind of stuff, we'll have already covered everything you need to know. Like I said at the beginning yesterday, it's a fairly simple language. The syntax isn't too hard to learn. But then for the remaining couple of hours, we will look at how relatively easy it is to get to do an awful lot of stuff with it by using external modules. And in fact, we will start off this morning by looking at how you use these external modules. I've just realized hold up. Need a second screen of some description to show, because otherwise I can't see what I'm doing. I completely forgot. Anyway, so as a Python, a lot of its power comes from all these external modules. And it has many, many external modules and things that it can use. It's actually very easy to import this as well, but you can do things like, reading in data, making plots, doing statistical analysis. Pretty much any field that has used Python at all will probably have its own modules available. So I know there's stuff for particle physics, for example, which is my field. I know there's stuff for biosciences and things too. And they are very easy to get hold of. They're very easy to get access to. So, and again, I did say this yesterday, before you start writing some big mammoth piece of code or something like that, have a look out there to see what's already been written, because that could save you an awful lot of time and hassle. In just 1 minute. So, how do you get access to an external module? Let me just log in on this. I will. Here we go. Right. I'm sorry. I'm just setting up a second thing next to me because I don't have two screens on mine. A spare screen attached to my MacBook. Right, so hopefully you've all started up Python again. Here's Jupyter for me. And I will, what should I do? Shall I keep that open? I think I'll start a fresh one. I think I'll close that. And I'll just create a new Python 3 notebook, just so I know it's clean. There's a clean notebook in there. Right, so how do you get access to these external modules? All you do is use the keyword import. So if you type import into Python, and then you just give the name of the module you want to import. And there are quite a few modules that are available in Python already. So for example, there's a math module that's got some basic math functions in it. So I can do import math, run that, and you can see no error. And now if you type math and press dot, just like when we ran functions on that we used functions that were provided by a data type, you can do the same thing here. Do math dot and then press tab, and here we have lots and lots of things that the math module provides. You know, you got sine, cosine, you know, trigonometric functions, all these kind of things. What I will do, that I will just set up a list first. So if I do nums equals 1 point, whoops, 6.8, 19 point. I've just set up a list there of 3 decimal numbers. If I do math.f, f is, I know that is a function provided by the math module, and give it nums. Now, if I run that, that will actually add up all the numbers in that list and return the result. I didn't have to write my own loop for that. I didn't have to, you know, do all that. I've done that in just that one line using one function. So not only is it readable, it's obvious what I'm doing with it because, you know, you can read the function. There's very little that can go wrong there. And for those of you wondering why I've got lots of zeros and then a 2 at the end, that's just a sort of rounding error because the way the computer represents floating point numbers. Don't worry about that. So this is indicative of why Python is so used. A lot of these things, you don't have to write these functions. You don't have to write how you do it. You just use the things that are already there. Not only can modules provide functions, so that was a function. Obviously, I used the brackets and gave it the argument of the list that I wanted to add up. They can also provide values as well. And probably not that surprisingly, the math module provides a constant for pi. So if I do math.pi, you can see pi there. So I don't have to remember to do 3.1414159 whatever, or set my own variable to it or anything like that. I can just import math, and then whenever I need pi, I use that. And there we go. Again, also readable, you know what's happening. Now, that's how you can get access to the functions. This may seem a little bit clunky because you've got to sort of have, you know, math dot, blah, blah, all of this. I personally am quite happy typing out sort of using a full explicit module name with a function or variable like that, because you know exactly what you're using there. But if you're using it a lot, it can be extra typing and it could make things a bit less readable. So you can actually rename things. Firstly, you can actually just pull in one thing. So if I want to, let's say I just want to import the fsum function. So you can do from math. So I'll say, right, I just want to pull in the math, from this math library module, I just want to pull in fsum. So I've got from math, import fsum. So as with a lot of things in Python, it does what it sounds like it's going to do. And now I can just run fsum like that without the math dot. So if I do that, you can see I didn't need the math dot at the front. Now that can be useful. You may want to do that, but may want to do that, but you also, well, you could have, there could be a conflict here as to what, if you have other variables that are called math or fsum or things like that in your code, but you want to use these external modules. I mean, it doesn't often happen, but it can happen. So you may want to also rename things when you import them. So to do that, you can, for example, do import math. So that's what we did before up here. There, and you can see that just gave us math dot whatever. But I can change that name if I import math as, and then another variable name effectively, because this is, you're just assigning this module to a different variable name. I'll call it sysmath, like that. If I run that now, instead of having math, though I would still have math in this notebook, but I've also got sysmath dot, and you can see I can, that works just as the math module did before, but it's named something different. And as I say, that can help you if you've got any conflicts with variable names in your own code. You could also, I mean, if you really wanted to be extreme about it, you could say from math import fsum as sys fsum. And now I've got sys fsum, whoops, fsum nums. And there we go. So you have some control about how these things are imported and what they're called and things like that. And that is how you can get access to external code and how you can use it. It's not too hard. You may need to look into the different modules and see what they can do and things like that. You can always use help for that. See, whoops, there we go. So I've just used the help function, and you can see all of this. Generally, if it's a well-written module, it will have provided the help for it. But to be honest, your easiest option is quite often just to type it into do a search for it. So, Python math module, and it will almost undoubtedly be the first hit. Well, there'll be various things, but here you go. There's the Python 3.94 documentation. And here is the official documentation for the math module, and you can see it details all the functions, everything that's available. So it's pretty easy to get help on these modules, and then you can see if it provides what you need, or at least gets you most of the way, and then you can just finish off the rest with the plain Python that you know. Okay, so has anyone got any questions about importing modules or using external modules? Doesn't sound like it. Okay, so we'll have a quick exercise here. This is so give this a try. This is quite a good exercise actually, just to give you an idea of how to get help on a module, look up stuff about a module, and also how to import it and use the functions and stuff. So give this exercise a go. We'll give it 5 or 10 minutes. I mean, if you're having trouble, either ask a question or just you can click on the solution. It's not a test or anything. But yes, give that a go, and then we'll move on after that.
So for installing new Python modules, there's a command line application called pip. And generally, most Python modules get installed through that. So you can type, after opening, on Windows, I think it's Anaconda prompt. You can type pip space install space and then the name of the package. That's generally the way that people would do it.
Yeah, any decent package will be available in the Python package manager, which is accessed through this pip command. So yeah, certainly if you've installed Anaconda, you should just be able to open up an Anaconda prompt or Python prompt. I can't remember what it is, but yeah, just type pip install, and there you go. I think someone was using just pure Python yesterday. That is going to be a little bit more tricky, but we can get around it. So. But we don't, generally, you don't have to, for today, if you've installed Anaconda, most of the packages you're going to need are there anyway, because Anaconda gives you a load of plotting packages and analysis packages and stuff like that. It would be if you wanted to add more sort of specific, more things that are specific to your field. But yeah, actually, yes, it's probably worth, just click on that actually, because it's worth having a look at the many, many, many project things that are here. Let me see. Ooh, natural language. There's some, ooh, all sorts. Framework. Oh, look, you know, there's Django. Right. Let's have a look for, I don't know, physics. So look, all of these modules are available by just doing pip install and then the name. So there's many, 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 many modules. Like I say, we won't need to install any today, but that is the kind of stuff that is available. Anyway, hopefully you've all managed to do that, or at least given it a go. I'll quickly work through it. So it says, we'll use the sys module, find the thing that corresponds to the search path that Python uses to find modules and write a loop to print out each one. So we start by importing the sys module. So we just do that, import sys. Now I've done that. Now I can do help sys, or I could just look on, you know, just search the internet. And if we go down, I already know what I'm looking for, so that makes it a lot easier. There's a lot in this sys module. When we get to the, here we go, we're in the functions now. You can see. And then, I missed it. Functions, here we go. No, it's not a function. It's not a function at all. It's a variable. There we go. Module search path. So that is where Python will search for modules, where it will load up these modules from. So we want sys.path. Let's just have a look at it. It's not a function, it's a variable, so I don't use the brackets. If I run that, you can see got all of these wonderful search paths in it. Yours will look different, quite probably very different. But then it asks to find the corresponding search path of Python and write a loop to print out each one. So as you can see, this search sys.path is a list. As we had a list yesterday with the loops, we can just loop over each one of those and print it out. So I can do for p in sys.path, colon, and now print p. If I run that, it looks very similar, of course, but you can see, actually, I will make it a bit more obvious by adding something there. There we are. So you can see each of the entries in that list, and I've printed them all out. So hopefully you've at least can understand what I've done there and how that's worked. Any questions on that? No. Okay. Moving on. Right, so this is now actually the last bit of Python I'm actually going to teach you. And after this, we'll be looking at basically using external modules to do some analysis. So we're looking at creating functions. So as I've said a couple of times now, reusing code is very important. And it means, it's good code development, and it will save you a lot of pain going forward. If you've got lots of copies of the same piece of code, if you need to change it ever, then you've got to change it in all the different places. There's more lines of code, so more places for there to be bugs. It's never good to copy and paste things more than once. In fact, copy and pasting things once is, so you've got 2 copies of something, is generally a bad idea. So how do we reuse our code? We've looked at loops. That's a prime way of doing it. The other main way of doing it is through writing your own functions. So we've been using functions up to this point on different objects. So the append function on a list, the print function, things like that. But in this section, we're going to look at how you can write your own. And therefore, you can take your own code, put it in a function, and then just call it however many times you want. And not only do you then avoid copy pasting, it also means it can quite often make your code a lot more readable. If you've got a big, 10 pages of code, it can be very difficult to isolate what's going on. Where if you sort of take bits of that out into functions, into their own bit of code, and sort of separate them out, you can deal with each sort of block in turn, and it makes it a lot easier to just understand, deal with, and also to find where problems are. So let's get going on this. So we'll start off by just defining our first function. And to do this, use the def keyword, short for define. And then you give the function name. And this follows the same rules as variables. So uppercase, lowercase, letters, numbers, underscores, but it can't start with a number. And also it is case sensitive, again, just to reiterate that. So let's do a conversion from Fahrenheit to Celsius. So Fahrenheit to Celsius. And yeah, I'm just following the material, as I'm sure you're aware. So you're welcome to keep that page up, because I'll be cribbing from that. So that's the name of our function. And then in brackets after this, we will indicate what arguments need to be given to the function. So if you, so for example, the print function, you can give that arguments, extra information for it to print out. If the function you're writing needs information to do its job, then this is where you would put it. And you just list the variables that need to be provided. So in this case, we need the temperature. So when I call this function, I need to give it a value there that will then get mapped to temp in the function. So the temp variable name, the temp label, will get stuck on that object. So either there'll be a copy or a reference, but it gets stuck on that object, and I can use temp in my function to refer to whatever was given to the function. So I've got def, I've got my function name, I've got my arguments, then I give colon. And as we saw with conditionals and loops, that means we need to give a code block. So if I press enter now, you can see it's been indented. And now I can just give the code. Let's start with just doing print. Actually, we'll do temp C, short for temp Celsius, equals, and I'm just going to copy this because I don't know what the what this is off the top of my head. Multiplied by 5 over 9. Apparently that's the conversion. Right, so there's my function. If I run that, nothing happens. It hasn't, and in fact, if I put, let's just print there. If I run it, still nothing happens. It has only defined the function, it does not run it. It's just said, right, I've taken that code, I've remembered it, it's in memory now, but I haven't run it because you haven't told me to. You have to actually call it. So I do Fahrenheit to Celsius, and let's do 32. Now, if I run it, I get that printed out, apparently. Check that's, that gives me a bit more of a sensible number. So that's good. I am now calling this function just as we've seen before, giving it the argument, the extra information, in this case 70. The code then, the program will jump to this point here. Temp will be assigned this value, and then it will run this code. After it's finished running that code, it comes back here. Now, what if I want to actually get that number, that value? You would assume you do this. So A equals Fahrenheit to Celsius, so that's a function being called, and then that, and I just want the number, actually I'll do temp C there, or my temp C, just to make it obvious what I'm doing with. My temp C equals that. So if I run that and now do my temp C, there's nothing there. My temp C, if I make it explicit and print it, is none. The reason is, though I am printing this, I'm setting this value, I'm not giving anything back from the function. I'm setting this variable here, I am printing it, and then I'm forgetting about it. I'm not doing anything with it. What I need to do is actually return it. So I use a keyword return and then give that variable there. That will actually give that value back to whatever called the function. So if I rerun that cell, so I'm redefining the function. Now if I run this, and now if I run that, now my temp C is set to that value. I don't think I need that cell. There we go. You don't have to return anything. So if you're in a function and you want to return before it gets to the end of the function and you don't want to return anything, you can just do a blank return like that. That will just say, right, I want to leave the function now, and it'll go straight back to the calling code. So, you could, if there's been you've done a check or performed some check in the function, and it said, and you've decided, no, I can't finish the rest of the code, or there's no reason to finish the rest of the code, then you just use return like that. But if you actually want to give a value back, you must specify it with the return keyword like that. So there's our first function. One other thing to note, actually, you can see we've created temp C there. If I try and just view temp C, now it has definitely run that function, because that we saw before, that's being set to a sensible value. But when I try and look at temp C, it says temp C is not defined, even though it has run through this. Whoops, what am I doing? There we go. The reason for that is any variables declared in a function, including the argument variables there, they are only available in the function, it's called termed in the scope of this code block here, or inner code blocks. So if I declare a variable in there, it is not available outside. And that's something you need to be a little bit careful with too. Okay, so we've got a function. Actually, before I move on to that, has anyone got any questions on that?
Mark.
Yeah.
Sorry. So technically, in theory, in order to, let's say in this is what in other languages is like a proc, it is a procedure, is a program.
Yeah.
Or a function, really. So
yeah, in Python, this is called a function, but yeah, you could call it a subroutine or a proc.
It's a subroutine. So technically, in reality, so if I want to save something, I mean, I need to, beforehand to specify, for example, okay, temp C, you will not find it, but my temp C will be stored.
Right. So
because temp C is what the subroutine returns. So it's like a general thing that doesn't go out of the subroutine. But my temp C gets automatically stored. So I can later on use my temp C with something else, for example, can't I?
Right. So maybe I think if I explain a bit more what's happening here, then it'll probably answer this question. So at this point, when I create this variable temp C in my function, an object is created in memory. So there's allocated memory. It's filled with whatever this equals. And then you get a label stuck on top of it, temp C. It hits this return statement and it's saying return temp C. It doesn't return the variable, which is just the flag. It's not returning this. It's not the thing that's stuck on the object. It returns the object itself. And then I am setting a new label on it, my temp C.
Yeah.
So the object stays there. It just gets my temp C stuck on it, and temp C is removed.
Yeah. That's what I meant. So
so my temp C now is, you can use that here. You can see it. It's now available in this scope.
Yeah. Exactly. So, for example, if you want to use my temp C for some other purposes, for example, retransform it to some other unit, you can call, let's say another subroutine, another function, and of course use that as an input for the function.
Specifically, I can do that.
Yeah.
I mean, it doesn't make a lot of sense, but I can.
Yeah, exactly. Sorry. That's yeah.
I mean, the number's complete rubbish, but it's that is perfectly legitimate.
Yeah, this is exactly what I meant. Okay.
Yeah.
Sorry, thank you.
So you can this after you've got the value back and this new variable name assigned to it, this is now just like any other variable that's attached to an object. You can pass it to functions, you do what you want with it. So
yeah.
Okay. Any other questions? No, doesn't sound like it. Okay, so we've got Fahrenheit to Celsius function. Great. Let's do another function, Celsius to Kelvin. So go from from Celsius temperature to Kelvin. So I've just copied the function, but I'll just do Celsius to Kelvin, and I'll just make it. I'm just going to change the variable names here to make it a bit more clear, because this is going to get a bit complicated otherwise. So we're having Fahrenheit as an input there. Here we've got Celsius as an input, and we're transferring to Kelvin. So I'm returning Kelvin. So we've now got two functions. Let's just check they both work. If I do, so that's Fahrenheit to Celsius, and Celsius to Kelvin. oops, I've got an error because it's saying name not defined because I hadn't rerun that, so I hadn't actually defined my function. Now I have, and now it works, and that's, I shall print both of them. I've just realized something else I haven't done. My conversion from Celsius to Kelvin is obviously wrong. And highlighting the issue with copying and pasting, you can go wrong pretty easy. Temp C plus 273.15. Okay, so we've got Fahrenheit, Celsius, Celsius to Kelvin, two functions, and they both work. Great. Now, what happens if you wanted to do Fahrenheit to Kelvin? Now, you could write, we'll do the function here. So we want to do Fahrenheit to Kelvin. So we have Fahrenheit coming in. You could sort of, you know, combine this and just have one calculation there, which is fine. And in this case, it's probably okay because, you know, you're unlikely to need to change that at all. But you're effectively duplicating your code. You would have to redo that a version of that calculation and combine it with a version of that calculation and have the same stuff there. If you did need to change it in the future, you would have to change it in two places. Whereas what you can do is use the functions you've already got. And this is called composition, where you are composing a function, or, well, in this case, a function from other functions. So what I can do is just say temp C equals Fahrenheit to Celsius with temp F, and then temp K equals Celsius to Kelvin, and use temp C there. So I'm getting the temperature in Celsius from using this function, and then I'm getting the temperature in Kelvin, whoops, from my temperature in Celsius, and then I can return it like that. And this code here, that is much less likely to change. That's not a calculation. There's not a lot actually, it's not actually doing a lot there. It's using things that are already there. Again, we come back to this idea of try and reuse stuff that either you've done or other people have done. So now if I do Fahrenheit to Kelvin of 70, I get an error because, again, I forgot to run this. If I run it there we go. We get what I would assume is the correct answer. Actually, let's just, I think that's correct. Fahrenheit, oh no, Fahrenheit's 22212. Yes, that's correct. There we go. So you can see this function here is doing very little. It's not, all the work is being done by these other two functions. And that's better. It's also more readable than having to sort of refactor these calculations into one calculation there. Okay. Right then, so that is that's how you write your own functions. There's a useful thing you can do as well, which, as I say, you could it can be quite a useful trick. I'm going to write another function now. I'll do def label print. And this is just going to be a function that takes a string or a message, and then we'll print it, but prepend it with a little sort of a little string that you give it here. So if I do print line, str message. If I run that, and now if I call that label, label print, now do my message classic hello world. And then we'll just have something like that, just a sort of prompt kind of thing. I run it, there we go. So there I've defined my function, label print, takes 2 arguments this time, separated with a comma. When I call it, I'm giving hello world as MSG and that as Linestra, and now I'm just printing it like that. Now, what could be annoying is if your function, you're going to call this function a lot, say, but 90% of the time you want Linestra to be that. You don't want it, you just want it to be that, you don't want it to be anything different. But then a couple of times maybe you do want it to be something different. It's a bit of a pain for each time you call that function to have to provide that extra argument when most of the time it's exactly the same. So to get around that, you use what are called default arguments. And to do that, you simply just do an assignment in your function definition, so up here, to what you want it to default to. So if I do that, I'll rerun it, so it redefines the function. Now, if I print as I had before, it's fine. But now, if I delete that, so I've just got the 1 argument now, if I run it, it still works because that 1 argument gets assigned to MSG, and then this is defaulted to the 3 angle brackets. I can change that though when I need to, so I can have instead that, and therefore, and that has overridden the default of that argument. So that this is how you will see functions where you don't. Sometimes you provide them arguments, sometimes you don't. This is how that's done. It's just termed a default, the default for an argument, and it means you don't have to provide it each time. Right. Let's see what the time. Oh, 5. Right. Okay. So I think. Yes, I think we'll probably leave it there for this. Just go back to material. Right, so any questions at all on defining functions and how functions work? No? Okay. So we've got a few exercises here. We'll give about 15 minutes for these, I think. So give those a go. Call out if there are any problems. Yeah, have a go at those. And after that, there's a couple of extra things I want to talk about, but then then we basically finished learning Python and we're on to just using it. So give those a go, and I'll start again at 20 to 11.
Cool. Thank you. I'm gonna have to leave. Bye.
No trouble. Thanks a lot.
Yeah.
Okay, so hopefully you've had a go at some of those exercises. Share, please. Has anyone got any questions before I move on? No, doesn't sound like it. So, so there were a couple of things I wanted to talk about just before I left functions. The first thing was, so if I go back to my label print function here, let's say, I'll change this. So instead of printing just a message, it will print all the elements in a list with that line string. So now if I do, so I want to loop over each element in that list. So I just use a for loop, LE in list, and then just print line str, and then LE. So I'm printing a line str and then each element, and that will loop over. That'll be done for each element in that list. So if I rerun that, and now I'll put hello in quotes and world in quotes, but it's now a list. So I've got 2 words there, 2 strings. I run that, I get hello and then world. Great. What actually now? What I will, if I take that, change it to my list, and now give my list like that. Again, it's the same thing, all good. What you do have to be careful with though is if in this function I also did inList.append all done as a string, redefine that. Now I run this, the printout works okay, but now if I look at my list, so this is my list here, that should just be hello world, all done has actually been added to it by that line in that function. The reason for this is because, as I said yesterday, lists are mutable, they can be changed. And when you are sending a list or a dictionary to a function, you are sending a reference to it. You are not sending a copy of it. So that means when I change inList in this function like that, it is changing the list that was sent. Okay. I can show this explicitly if I add a function call there to say it change that to a copy, so that forces it to make a copy of that list. If I run that and now have a look at my list, it stays as hello world. It has changed the list it was given in there, but because that was just a copy of my list, it doesn't matter. So that is something to be aware of. If you're sending dictionaries and lists to functions or writing functions that are using them, if you change them, there's a good chance you'll change what list or dictionary was sent. Now that may be what you want. So, you know, that could be a good thing, but it's just to make you aware of that. So that was an issue, was something I wanted to mention. The other thing, so we're now sort of gone past, gone through function or creating your own functions. Briefly on this errors and exceptions, I'm not going to spend very much time on this at all, because I mean, you undoubtedly already seen various errors and exceptions, but just to give you an indication of, Python does try to be as helpful as it can be when it hits an error. So, I mean, yes, as I say, you've obviously seen a typical error, say a name error when it can't find, it's not defined. So as you can see, it will tell you, it'll point to the line where the problem is. What's quite useful though, is if I put in, let's say in my Celsius, going back to my temperature functions here, if I change in Celsius to Kelvin, if I made a typo, so temp_c, that variable isn't available. It's not equals temp C. if I try and run that now, if you look at the error that you get back, you can see you don't just get, it doesn't just tell you this is where the error is. Look, it tells you how it got to that point. You get what's called the call stack. So you can see at the top, we've got, it ran this code and called this function, Fahrenheit to Kelvin. Within Fahrenheit to Kelvin, it called this function. You can see this is where the error, so I don't know. That's where the error occurred. But within that function, that's where the error occurred. And within that function, that is where the error occurred. And at the end, you can actually see the exact point where the error occurred. But that is useful because it may be that the function here, Celsius to Kelvin, was fine, but the information that was sent to it was wrong. And if it didn't tell you how it got to that point, it would be almost impossible to figure that out. So do have a good look at the errors Python gives you. They are usually very helpful and can tell you, pinpoint exactly where the problem is. So I just wanted to point that out as well. Okay. Right, so as I promised, that is all the Python that I was going to teach you. We are now going to look at using external modules to do some more complicated analysis kind of thing. So we're going to start off by just loading some data into Python. If you, let me just, actually, I will create a new notebook because that's getting a bit too full. Hopefully, so I'm in my Jupyter file browser thing here. You've downloaded the data files and you'll have these CSV files. And if you look at those, they will just be, rows of data, comma separated data. So let me create a new Python notebook. I'm just going to see if this works. Yes, it does. So in Jupyter and in IPython, if you do exclamation mark and then give a command, that will be like a shell command. So I know that ls will list the data. This doesn't work all the time, and in Windows it can be a bit iffy, but it helps. It can be a bit quicker than switching back and forth to a text editor or things like that, just so I can see what's going on. Right, so hopefully you've got your data folder here. As I say, in your data folder, you have these information files, and in those files themselves, there we go. If I look at one, you can see you've got lots of data that's comma separated. This data is representative. I mean, it's not real data, obviously. It's a representative of inflammation data for arthritis patients. So they're given a value of how much pain they're in to see if their treatments are working and stuff like that. Each row holds the data for a single patient. So that row there is the values for a single patient, and each column, so if you loaded it up in Excel, you've got rows and then columns, each column is the value for that day. And I can't remember, let me just see. Okay, I didn't like that. Stop. Oh, there you go, 60. So there are 60 patients and 40 days, 60 rows and 40 columns. So that's the data that you've got. As I say, at this point, we're now just talking about data formats, the files you've got, things like that. This is now not Python explicitly. So how are we going to load that into Python and start doing things with it? Now, you may think, well, I could, how to open a file. I think, have we done that? I can't remember now. I'm getting confused. Well, you can open a file, loop over the lines, read in data, things like that. Or you can actually use external modules. Specifically, certainly if you've installed Anaconda, you can use the NumPy module. That has a function called load_txt, and that will actually load in this sort of row and column data. And then it will give you an array, which is its own kind of data type, an array with all the data in it. And then we can do things with that. So now you actually have all the information you need. If you read through this exercise here, given everything you've worked through, you can import the NumPy module, use the load_txt command, and you need to specify the fname argument, so fname equals, and then give the file name. And depending on where you are, you may need to give, say, data / whatever. And then the delimiter argument, again, delimiter equals equal to a comma, because by default it's on spaces. Assign that to a variable and then print the variable to see what you've actually loaded. So that may sound complicated, but when you see how to do it, it's not that hard. But it's worth giving it a try by yourselves now to see if you can do it. So take 5 minutes and using what's given there, that text, see if you can load in the data. Okay. Don't worry if you can't, because I mean, firstly, the solution is there, and secondly, I'll go through it myself. But give it a try yourself, because learning how to do this yourselves is the main is part of the point of the course.
Just going back to when you were saying we should look at the errors reported, back in the Fahrenheit to Celsius, like temperature example, I got an error and I can't figure out what the problem was. Could I share that with you?
Yeah, are you okay to share it here?
Yeah, that's fine.
Okay.
I just need enable sharing.
Oh, right. Hold on. Oh. Apparently, it is available.
Ah. Yeah, looks good.
Ah, right, cool.
Okay, it was. Yeah, here.
Right. So again, we'll look at the error at the bottom to see what the actual problem is. So name Fahrenheit Celsius is not defined. Now, if you have a look at the specific name it's got there, Fahrenheit to Celsius.
Ah, I see. That's really simple. Okay, I thought it was going to be more complex than that.
You'd be amazed how many bugs and problems are actually just little typos like that.
Yeah. So that is up here. Yeah. Okay.
Yeah. So if you change that. Oh, and actually, I think you've got a typo on the second of those functions as well. You've got Celsius to Kelvin.
Yeah. Okay. Cool.
You're using so you need to be consistent with how you're going to spell Celsius.
I see. Okay, I'm going to stop sharing my screen now. I see what the issue is.
There you go.
Thanks.
Yeah, each time you run it, see what Python complains about, fix that, run it again. See what Python complains about, fix that, run it again. It's debugging is an iterative thing. You just you keep going and going. But this is why breaking things down into small problems, only dealing with a little bit at a time and getting that working is generally a better idea. Right then. So hopefully you've had a look at, managed to have a look at that. But as I say, I will go through it anyway. So let's just delete that. We don't need that anymore. Right. So the arthritis data is recorded in comma-separated list files. To load this, oops, full stop. Use the function load txt provided by the NumPy module. So that's the this is the NumPy library here. You can have a look at the documentation. It provides an awful lot of functions. You can do all kinds of linear algebra. There you go. Matrix libraries, random sample, all of these it provides an awful lot. So, but we care about the load txt function. So let's get access to NumPy first. So it's a module. It's almost certainly, if you're going through Anaconda, it will be available to you. So if you type import NumPy, just run that. Now let's just check NumPy dot. If I press tab, and here we are, and you can see all of these many functions and variables that it provides. But we want the load txt function. So we're using the load txt function from the NumPy module. You could have done from NumPy import load txt, and then you just need to type load txt. But I'm going to keep it as importing NumPy. So that's the function we want to use. And we want to use the fname argument. And that will be the file name. So the fname argument. And what you can do, which I knew that was something I forgot about with the functions, you can specify, you can name the function, you can name, be explicit what each argument is set equal to. So I can do fname equals, and then give my file name. If I can remember what it is. Oh, there we go. Tab complete is your friend. So that's saying I want the fname argument of this load txt function to be explicitly set to that. Then I need the delimiter argument set to comma. Delimiter equals, oops, comma. And then it says, assign this to a variable and print the variable to see what has been loaded. So I'll just assign that to data, run that. Now if I print data, I've got my data loaded up. So that is, so without needing to worry about, doing much about doing loops or opening files or anything like that, I have now got all the data in that CSV file into Python, and I can now do analysis with it. Just with this, well, I suppose 2 lines, that importing NumPy and then loading it up with that line there. So oh yeah.
Mark, sorry, I went in a slightly different way,
Mm-hmm.
in the sense that what I actually did was I wrote import NumPy,
Mm-hmm.
then data equal NumPy dot load text, then the file name, and then I put the old file path.
That's fine. Certainly, if you didn't get an error, then it would have loaded the file.
Yeah, it looks pretty much similar to yours. Didn't get any error. It looks similar to yours, but generally speaking, it works like in the same way as many other programming languages like MATLAB or it's like an import file basically.
Yeah. So the file name here, it depends where you're running Python from. So this Python notebook is stored in this directory here. As you can see, I've got my data directory, and there's all the information files. So I've got to say, I've got to give it data, then / and then the CSV file. If I'd started it in the data directory, I just need that. But what you can do is actually give the full path for, you know, / for Mac, it will be /users /
Yeah, that is because I use the Mac. That is because I use the Mac. So
yeah, that's fine. For Windows, you know, you'd be C:/ I suppose, but I think Python will translate it anyway. So C:/ / blah 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 blah. You can use the full path if you want, as long as basically as long as it can find it at that location, you will be fine.
okay, thank you.
Right, so we've got our data loaded up, but what actually is our data, or at least what is our how's it been loaded up? I've printed my data and it looks a lot like a list of lists. So we've got a square bracket there and a square bracket there, and then, you know, square brackets there and there. And it's obviously decided not to print everything because we got these dots everywhere. To find out what type something is, the type function. So if I do type of, just as an example, that, you can see that comes back as str. It's a string. If I do type of 10, that's an integer. So let's have a look at what type this is. So type data, and it comes back with numpy.nd array. Now, this is not a built-in Python type. This is a type that has been provided by NumPy, but that shouldn't worry you or bother you. The same rules that we've learned about types and objects of a certain type and things still apply. So, okay, data is a numpy.nd array, but that type will provide functions. It will have a way of interacting with it and working with it that will be, you know, it will map very closely to things you've seen before. It will still use the same syntax, but it would, you know, it will have different functions provided to it. You can access it in different ways and things like that. So that's something that NumPy has provided. That is not available in plain Python. So two things we can look at, for example, is well, firstly, we could just do data and then dot, and if I press tab, again, it comes up with all the functions and variables that type has provided, this ND array type has provided. And you can see we've got all of these that we can do. We can try and pick up on a few of them. Dot product, I guess, I think that would be. Find the maximum, find the mean, reshape things, sort them, all of this kind of stuff. For this particular type, some things you would want to know is what is it got inside it, what are the data types inside it, and also what's its shape, because it's obviously imported a two-dimensional, you know, a matrix kind of thing. So if I do D type, the type of data, so these numbers are represented by another different type of information, which is a D type float 64, and that you don't care about that really. I can say that that's just a really, really accurate floating point number, but again, you don't care. It's just another type that again will have things associated with it. So it's a different way of storing numbers. And if you look at the shape, you can see we've got 60 by 40. We've got 60, I always get this wrong, 60 rows and 40 columns. So we've got 60 patients and 40 entries for each patient, so 40 days. So that gives you the shape of the matrix or array that you've got there. Now, again, the way just for this data type, so you can access it easily, you can use the same stuff that we learned for lists, because those access methods are the same. So if we do data 0, 0, we get the top left entry there. Or we could do data 0, 20, and we get the 0th row and the 20th column. Let me just check that. If I go out of range, index 50 is out of bounds. So there we go. And actually, this doesn't apply to lists, but for this operator, for this type, you can actually do it like that, which, oops, there we go, which can make it a bit easier to read and sort of map onto other languages like R and stuff like that. So you can do 0th column, 0th row and 20th column. Note though, still 0 indexed. Okay. There is actually a quite useful image here that indicates how these things are mapped. So 0, 0 would be A, down to 0, 2, which is C. So the second index is the column and the first index is the row. Now, as I said again, all the way back when I was talking about operators, operators are nothing special. If the code is provided for them to work on different types, that's the code that will run. So for these arrays, you can do things such as something like this. So I'll call this double data equals data times by 2.0. Run that. And double data, oops, you can see the data has been doubled. You've got a copy of the array and all the entries have been doubled. So that's pretty simple. Just going back to accessing it again, we can use the slicing method again that we learned with lists. So let's say we want let's say let's see what can we grab. Let's grab the first column. So we want to have the first, actually no, we'll start with the first row. We'll say the first row, 0. And if I want all of that row, so if I wanted just the top left point, that's that. If I wanted the last point, because I know it's that size, it's that. If I wanted the whole row, you can use slicing. So I'm using 0th row, I can just do colon, which would be from the beginning to the end, and I get the whole row. Or I could just have the first half, say, and I get the first half. Or the second half, like that. You can do, say, if you want the first, a similar thing works for the columns as well. I want all the rows, but only in the first column. And there we go. And you can see they're all 0 apparently. Or the middle column. And there we go. So you see you've got quite a lot of power for how these things can be manipulated, how you can access them and stuff like that. Looking at what we've got for functions that can run on it, one of the that I pointed out in the list there was you can get the mean. So I can just do data.mean. So this is the original data that I loaded in up there, and I'm running the mean function provided by that ND array data type. It's a function. I need the brackets, but it doesn't need any additional information. And that will give me the mean of that whole array. Just like that. I didn't have to write my own loop or anything like that, just mean, done. And as I say, there's lots of other similar examples, similar functions that you can use. So there's the max, and that will give the maximum in the data set, min, and in fact, and you can also easily just do the standard deviation as well. Now, just to give you a chance to sort of make sure you can load this data in and start using these things, have a look at this exercise here. So using what I've shown there about slicing and the functions, see if you can figure out how to calculate the mean value for just a single patient, one of the rows, and also just a single day. So 2 values, single patient, and then single row. So see if you can do that. We'll give you 5 minutes or so, up to about 20 past, and then I will go through that. But that should give you a bit more experience using these new types. Okay, so let's go through that. So we wanted the mean for a single patient, which would be a single row. So we specify the row, and then we want the whole row. So we just have colon, because we could do a particular range there, but if we do just a colon, we go from the beginning to the end. So that's the value for a single patient. And then I think I can do this. I'm not sure whether this will work. Oh, yes, it will. There we go. So I have got there the array for a single patient. And so therefore I know that's an array, and I can call the mean function on that. So I just do dot mean. You could, of course, do, and this may actually be more readable, patient equals data 0, that, and then do patient like that. That's absolutely fine. Going back to what I had before. The other option is NumPy provides a mean function that you can then give an argument to, as opposed to running the mean function that's provided by the data type. There's a generic mean function that you give the data to. So I can do NumPy dot mean and then give the argument like that. And again, it works. So that's for a single patient. To do a single day across all patients, you just reverse that. So you go over all rows, but only one column, like that. So has anyone got any issues or problems with this so far? No? Okay. So moving on. Now, what we've looked at the moment is we've said we've got given the mean of a single patient or a single day, and we work out that number. But quite often we'd like to look at, say, the mean for each patient or each day, or the standard deviation for each patient and each day. But instead of having to write our own loop to do that, because you could loop I in range 0 to 40, and then do that. So that's printed out the mean for each day, like that. NumPy, the ND array actually provides you with a way of doing this in one line. So if we have a look at this, all these kind of mean, max, standard deviation, all of these kind of things, have an option of an axis argument, and that will perform that operation. And again, I always get this wrong. I've got to think about this. Along that. No. Okay, so if you give axis 1, this is why this plot's here. If you give axis 1, it will condense down to just the patient. So you'll get an average over each patient like that. If you give axis 0, it will give a result for each row. Okay? Yes. So for each row, you want axis 0, which would be the first. So, and for each column, you want axis 1. So if I do numpy.mean, and I just give data now because it's, I want to run over all the data, but I specify axis equals 0, that will do it for each row. You will get a value for each, I've got that wrong, haven't I? For each column. This can be confusing. So there we go. So for each day, I get the average. If I want it for each patient, I switch to axis 1. Again, refer to this. So axis 1 will give you, will sort of squash the days, or do it over the days, over that axis. Yes. So axis 0, you get it for each, you get a value for each day. Axis 1, you do it for each patient. But again, you haven't needed to provide your own, do a loop or anything like that. And the same can be done for standard deviation. So there we go, that's a standard deviation for each patient across all 40 days. I'll avoid that. Okay, so that gives you a bit of an idea of how these NumPy arrays can be used, how you can start doing, as you can see, you know, we're now just running single functions and we're getting already quite complicated analyses done. If we have a look down here, try and give this example, this exercise a go. This is quite an in-depth one, but it's worth working through if you can do it. So it's saying this patient data is longitudinal, so it means in that it's relating to it's a time-based study. So you've got observations each day. So the change in inflammation over time makes sense. So it will be interesting to see how the scores for each patient change day to day. And NumPy provides a function that does just this, the .diff function. And that will take a NumPy array and return the differences between the two successive values. So if you had, if you gave it an array that's 0, 2, 5, 9, 14, you would get back this here. You get 2, because that's 0 to 2, 3, 2 to 5, 4, 5 to 9, 5, 9 to 14. So that gives you that difference. So that gives you an idea. So try and use the diff function and work through these questions here. And you will hopefully see that with only a few lines, you can actually do quite a complicated, you can get some fairly in-depth answers about your data set fairly quickly. So give that exercise a go. Call out if you've got any questions or problems. We'll have probably 15 minutes on that because that's quite a tricky one and it's worth persevering with it. If you've got any questions or problems, just call out and yeah, see how you get on. Right then. So just go through that exercise there. So as I say, we've got this diff function available on arrays. And the first question is, which axis would it make sense to use this function along? Because, and how would you create an array of these changes? So obviously you want to do it in the time across each day, the difference from day to day, because it doesn't make a lot of sense to go from patient to patient. So referring back up here, you want to do, you want to end up with the difference across, I'm going to have to look at the solution. I think it's solution axis 0. Oh no, it's axis 1. There you go. Since the row is axis 0 of patients, you don't want to do it across across the rows, axis 0. You want to go across the columns, which is axis 1, like that. So you want it to go across the columns, which is axis 1, which is for time. So let's do that to start with. If Zoom would just remove its thing, there we are. So we've got our data array, and we'll do numpy.diff, give it data, and we want to go across the columns like that. And so now, if we have a look, we can sort of check the first row here. 0 to 0 is a change of 0, 0 to 1 is a change of 1, and 3 to 0 is a change of -3, 0 to 0 is a change of 0. So that's correct. That's what we want. If the shape of an individual data file is 60 rows and 40 columns, what would be the shape of the array? And what would the shape of the array be after you've run the diff function, and why? Well, we can actually just have a look and see, because we've got this answer. So we can just say, what is the dot shape of that array? And we've got 60 rows still. So we've still got 60 patients, but we've now only got 39 columns. And that makes sense, because if you're doing the difference between each column, you're going to end up losing one column. So there's one fewer differences between columns than there are columns in the data. So how would you find the largest change in inflammation for each patient? Does it matter if the change in inflammation is an increase or a decrease? So, go away. There we go. So how would you find the largest, the greatest change in inflammation? So we've now got, that gives us our change in inflammation from day to day for each patient. So we want to do the maximum, don't we? So so we can do numpy.max of that. But we need to specify that we want to do it on axis 1 again, because we want to do the maximum for each patient. So if I run that, so yeah, we're doing the maximum across the columns, so it's axis 1. And so that should be for 60 patients. Let's just check. 60, yeah, so we've got 60 values. Now, one thing it did mention, does it matter if the changes in inflammation is an increase or a decrease? Well, actually, yes, it does. Because, for example, if I change that to min, what's the minimum change? We actually get a lot of negative values, and we want the actual maximum, the greatest change, not whether it's up or down, just the greatest change. So we've still got our data there, but what we want to do now is actually do numpy.absolute, or infer all that. So we start off, okay, so we start off with our data. We get the difference of our data going across the columns, axis 1. We're going across all of axis 1. But now we want to make that we want the absolute value of that. So in other words, removing any negative signs. Again, that needs to be done axis. Actually, no, you don't. That will just do the absolute for each of those numbers, so it'll keep the shape the same. Then we want the maximum of that absolute value, again, across axis 1, across all the columns. So if I run that, that should get you, and if you think that line there will give you the maximum change in inflammation for each patient across those 40 days. And you've managed to do that. If you count up the total, I mean, that would be effectively 3 lines of code, because I would have done import numpy, data equals numpy.load txt, etc. And then that line. So in 3 lines, I have managed to do quite a complicated bit of analysis, or just done something quite it would take you a bit of time to code that if you were having to do all the loops and all the things yourself. So that is what the kind of thing that Python allows you to do, using these external libraries, external modules, and chaining them together using the Python syntax to produce some pretty advanced analysis pretty quickly. Okay, so any questions about what we've done there? No? Okay. So now we're going to look at, again, using external modules, but we're going to do something even more fancy, as it were. We're going to actually look at visualization of data, so making plots, basically. And as before, we're not going to do it ourselves. We're not going to try and do our own, draw lines for our graphs or anything like that. We're just going to use an external package. And the general one that people use for scientific plotting is matplotlib. The way you do this, again, import, but it's a little bit more weird because it's based off, essentially, it's kind of based off MATLAB kind of syntax. But we need to import matplotlib.pyplot like that. It takes a bit longer to do that, but that should import that. And then if you do image equals matplotlib.pyplot, again, I mean, you don't have to worry about the specifics of this. You can look up what these things provide, but effectively you're just accessing functions within this module. And to start, do show data. And this will produce a heat map of the data that we've got. So if you run that, there we go. One line, and we've now got a heat map of the data. We've got our 60 rows, our 40 columns, and you can see it sort of go from that heat map. You can kind of see it does that. So there you go. Just to produce a heat map of data, there you go. Now there are many different plots. There are many. You can add legends, change styles, all of this kind of stuff. A whole load of stuff you can do with matplotlib as well. We're not going to look at it at all. We're just going to. But the main takeaway is to sort of be aware that these things can be done. So quite a nice, pretty looking heat map. You probably care more about, you know, a line or something like that. So let's do, let's plot the mean all days. Now cross, so all, across all days, across axis 1, want to average across all rows, that's axis 0. So I will do axis equals 0. And oh, I'm breaking up, am I? Oh dear. Hold on. I suspect that may just be my my internet connection becoming unstable. Oh, good. I'm back. That's okay then. So hopefully you've at least seen the heat map there. So yeah, we're now going to look at the mean value for all patients for each day. So we're averaging across the rows. So we use axis 0. So if I now just check that. So this will have this should have an entry for each day. So let's check the shape. So we should have 40 days. Yep, that's correct. So we want to make a plot of that. And so we can just do matplotlib.pyplot. This time, instead of you doing imshow, which is for a heat map, we can just do plot as inf. And there we go. We have our line plot. Now, what you can do, you can label axes, you can do, you could, instead of doing, so that's the mean there, you could actually just take that and do, say, the mean value, which looks a bit weird, and the max value, which looks even stranger. So you can, obviously there's something a bit off with this data, but you can easily start sort of producing plots, changing the data, changing what you're looking at, things like that, to get start doing analysis, actually finding out what your data is and figuring out what it's telling you. So that's how you make a single plot. You can actually also make, you can make subplots, label things, also, as I say, all sorts of stuff. So if we look down here at the material, you know, I am just going to copy and paste all of that. And this will, but we will look through it. You can see, actually, I'll copy paste it first and then we'll, I paste it in here. So it's not run yet, but we can just work through it. So we're importing, am I breaking up again? So if you can't get it, is it importing matplotlib? Oh yes, yeah, try. That's a good idea, yes. You may need to, so with Jupyter, it will just print the plot that you've got, but you may need to, if you're writing a script, do the following. If you do my plot equals that, and then, or in fact, just do matplotlib.pyplot.show. That will be the key line that you might be missing if you're just doing it in IPython. That creates the plot. When you've finished sort of tinkering with it and stuff like that, that will actually show the plot. And in fact, we'll see that here. So, yeah, as Ryan's put in the chat. So if you do, we're importing NumPy. We're loading in our data. So this is all stuff we've already seen. Here we're creating a figure. Figure is something that holds other plots or holds subplots and giving a size. We're adding a subplot, and you can look up as I say, it's I find it a somewhat weird syntax, but it's based from MATLAB. Add another subplot there, add a label, plot it, add another label to this plot, plot it, blah, 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 blah. And then finally at the end here, it will show the whole plot. So in fact, let's try commenting that out, run that. Oh, yes, if I look at the error here, information 01.csv not found. That is because I'm not in the correct directory. So if I run that. So again, in Jupyter, it will show it anyway as you do it, but outside of Jupyter, you probably need to do that as well. But as you can see, we've now got 3 plots in our figure added there, and we've plotted the mean of the data, the max of the data, and the minimum of the data. We've labeled our axes. And we're getting a few more lines of code now, but the lines of code here are primarily just to arrange the plots and things like that. One quick point before we have a look at, you can start having a play. You will very often see, because NumPy is used a lot and matplotlib is used a lot, you'll very often see plt dot whatever, np dot whatever on Google. And it's generally assumed that you will have done import NumPy as np and import matplotlib.pyplot as plt. So when you're looking on Google for, when you search the internet for code and things like that, that is where you will see that shorthand a lot, simply because having this typed everywhere is a bit of a pain. The last thing I will just quickly do is, if you do a search for matplotlib examples, here we go. This is a good way, because as I say, matplotlib is so big, you can do so much with it. It's a good idea. Just have a look at examples and see, and then you can have a look at the code for how to do it, and that will. So there you go. To do that surface plot, very pretty. Just click on it. You can see, and as you can see, import NumPy as np, import pyplot, blah blah blah. But that will tell you how you can do these kind of plots, and also give you a good idea of just the kind of things you can do. But if you find a nice style that you like or things like that, just copy the code and use that. But you can see we've got lots of spiral things, all sorts of fun stuff that you can do. Well, okay, so that's a very quick introduction to plotting with matplotlib. Again, and I know I keep coming back to this, but it's kind of the main takeaway. Python, the way to use Python is to use it to control and use other libraries, use other code that people have developed for plotting, for data analysis, things like that. That will get you most of the way, and then you can use the basic Python syntax to sort of fill in the blanks and stick it all together how you want for your particular problem. Okay, so there are a few exercises here. Do feel, have a look at those, or if you want, just start playing around with the data, start, 15 minutes on that, and then I will finish up with what's next. Yes, we'll have another quick look at how you do analyze data from multiple files before we end. But yes, have a look at have a go at those, and as always, call out if you've got any problems. Okay, so we're going to be finishing off now. Before we do, has anyone got any questions about anything that we've covered? Doesn't sound like it. So just to say, there is more material here that you're more than welcome to go through. For example, just to very briefly go over it, the next section would be how to analyze data from multiple files using the glob module. Again, just import the module and then you can use it. This one is one that is available in vanilla Python, and this works like the glob expansion in shell. So you can do inflammation star.csv, and that will give you a list of all the file names that match that pattern, and then you can just loop over them and analyze them all in a loop. So again, you're using something that is provided by Python or someone else, but then use a little bit of basic Python, a loop, just to go over it, and then you can perform your analysis on each file in turn. So that's the kind of the way, a good way to go about using Python. Right, so I think if I stop sharing, I think that's pretty much everything that I've really got time to cover, and also that I really wanted to cover. I don't think there's much else. So I believe, unless anyone's got any other questions, I think I will click the polling button, and I am assured by Debbie that all your responses will get automatically saved where they should. So here we go. If you could just leave your feedback, let us know how it's gone on. We're still trying to sort of, I mean, we've only been running these online ones for a few months now, so we're still finding our feet, I think. So any feedback would be very welcome. So I will click that now. Launch poll. Away we go. So if you could just spend a few minutes filling out those questions, that would be very much appreciated.
So going forward, are there any, this was my introduction to Python, and it's been a really great introduction, but would you recommend any specific resources for sort of taking it a step further or practicing, any books or?
To be honest, books these days anyway, not really, or not personally. There are books out there. There are very good books out there. But I would say now you've got a grounding with this course about the basics of Python, the best thing you can do now is just get stuck in and start doing stuff, because that will, I can end poll because everyone's voted. Thank you very much for voting. Share results? What was it? Oh no, don't stop that. Right, okay, done, go away. Yeah, so I would say that, oh, it's come back, go away. The best thing you can do, and to be honest, the best way to learn any programming language or any coding is just experience. You're not going to become brilliant at it in 2.5 days. You just need to sort of think, right, okay, well, I know I've got a good idea what is possible with Python. Now let's see if I can apply it to a problem I have or some data I've got, or, oh, how would I go about solving that problem? And then just start doing it and see how far you get. You're not going to break anything. It's not going to matter. The worst you're going to do is get an error. So you just say, right, okay, well, how would I've got a CSV file of data that maybe I would normally import into Excel and do a chart or something like that. How hard or easy would it be to do that in Python? So, and there you go. There's not for data analysis, data science, that kind of thing. I'm serious when I say there's not really any more Python you need to learn. It's now just about discovering what modules are out there that can help you do what you want to do. Those actually, having all that being said, I would recommend looking into pandas, the module pandas, which, in fact, I can bring it up, can't I? Because technology and all that. If I just search for pandas Python, here we go, data analysis library. I mean, it depends very much on what you want to do, but I would recommend looking at pandas mostly because it works in a very similar way to R, and R is another popular way of doing data science. So if you learn pandas, if you learn how to analyze data in pandas, you can transfer that to R and vice versa. But yeah, the best thing you can do is just try stuff out, really, and give it a go. If you got problems, I'm guessing my email address has been put somewhere, or you can, email Debbie and she'll pass your message on to me if you've got any actual problems. But there you go. Aslam's put in the chat. LinkedIn has many courses as well. But with the basics of Python, it is now just sort of experience, looking at code, trying to understand it, and just trying it yourself. And to be honest, I would say I would very much spend a few weeks and months doing that before you even consider doing any other more advanced courses or anything like that, just so you've got the syntax in your head, and when you look at code, you can understand what it's doing. And then you can look at more advanced courses, maybe that are looking at specific things to your field. Okay.
Thanks, that's really helpful.
Great. Okay, so last call. Any other questions or issues or anything you want clearing up? Anything at all, well, Python related preferably.
I've got like an observation rather than a question, which is like when I'm trying to write this code and I'm using tab to autocomplete, like often just nothing will happen.
If you're in Jupyter, it can take a bit of time. If you haven't auto-completed that particular module before, it will have to load in a lot of stuff. Okay. So I have found that on Jupyter it can be a little bit slower. IPython, it's usually pretty instant, actually. It's very quick.
I'm on Jupyter.
Yeah, so I've noticed that it can take a bit of time to load stuff in and render the box and stuff like that. But yeah, you just have to be a little bit patient with it.
So don't mash
the other
tab.
thing is, sorry, sir?
Is that don't mash tab, press tab, and then wait for a bit?
But yeah, well, you won't do any harm, but yeah, it'll probably just like flick up the box a few times and then go away. Yeah, it won't speed it up, certainly, I don't think.
Okay. Thank you.
Right, well, if no one's got anything else, I think a lot of people have left anyway. We've only got a few of us who aren't hosts. Right, well, thank you for attending. I hope it was useful. And let us know, as I say, if there's anything else, do get in touch with Debbie. If my details haven't been put out, I can't remember where they are or not. Thank you to Ryan for helping today, and Mike yesterday, and Aslam as well. And yes, all the best. And yeah.
Thank you very much. Thanks.
Okay.
Thanks very much, Mark.
Bye.
Yeah, went okay?
Excellent.
Well, good. Right, lunchtime.
Okay, I'll close the call then.
Yeah, take care, Aslan. Bye.
Bye.